Hello, everyone. Today, we're diving into a crucial topic for any aspiring or experienced engineer: multi-region load testing. In an increasingly globalized digital world, our applications serve users across continents, each with unique network conditions and expectations. Relying on single-location testing is no longer sufficient. It's like practicing basketball by yourself and expecting to win a championship game. We need to simulate the real game, with all its complexities and challenges. This lesson will equip you with the knowledge to build and test systems that can withstand the unpredictable nature of global internet traffic and regional outages. By the end of this session, you will be able to, first, understand the critical need for multi-region load testing in modern distributed systems. Second, you'll learn the core components that make up a robust global testing framework. Third, you'll be able to simulate real-world traffic patterns and regional disaster scenarios. And finally, you will validate your system's resilience and ensure graceful failover, building truly robust applications. Let's get started on building more resilient global systems. Why does multi-region load testing truly matter? Most engineers test applications from a single location, perhaps their office in New York. But your users are everywhere. A user in Tokyo connecting to your servers in Virginia will experience vastly different performance due to network latency than someone connecting from a neighboring state. This fundamental difference is often overlooked. Single-region testing is a vital first step, but it's like practicing basketball alone. You never encounter defenders or referees. Multi-region testing, however, is the real game, revealing problems you never knew existed. The impact of not testing globally can be severe. Remember Amazon's US East 1 region outage in 2021? Many globally distributed services failed completely because they hadn't properly tested what happens when an entire region goes offline. Companies lost millions in revenue simply due to untested assumptions. To prevent such disasters, our testing must validate three core concepts. First, geographic distribution, simulating users from different continents with varying network conditions. Second, failover validation, ensuring your system automatically routes traffic when a data center loses power. And third, cross-region performance, understanding how issues in one region affect users in others. These are the pillars of real-world system resilience. So, how do we build a system capable of this sophisticated multi-region testing? Our framework is composed of three major interconnected layers working in harmony to give you a comprehensive view of your application's global health. First, we have the dashboard layer. This is your control center, a beautiful web interface where you can initiate tests, trigger simulated failures, and observe real-time performance metrics across all regions. It's designed for clarity and immediate insight, showing you color-coded indicators for region status, latency, throughput, and error rates. Next is the service layer, the brains of our operation. This layer consists of three specialized services: a load generator service, which doesn't just spam requests, but simulates realistic user behaviors like browsing timelines or posting content; a failover service, which manages region health states and can simulate gradual degradation or complete failures; and a metrics service, which collects and analyzes performance data like P95 latency and success rates from all regions. Finally, we have the regional infrastructure. These are our simulated geographic locations. Think US East, Europe West, Asia Pacific Southeast, each generating load that precisely mimics actual user traffic patterns from that specific region. Together, these layers provide an unparalleled testing environment. Let's trace the journey of a global load test from start to finish. Imagine you've just clicked Start Global Load Test on your dashboard. The process unfolds in 5 clear steps. Step 1. Test initialization. Your dashboard sends the test configuration, outlining how many virtual users and what actions they should perform, to all regional load generators simultaneously. Each region gets its marching orders. Then, Step 2. Parallel execution. All regions begin generating traffic at the same time. This isn't random spam. Each generator creates realistic request patterns, mimicking actual user behavior. For instance, US East might simulate 25,000 users, while Asia Pacific handles 40,000, reflecting real-world user distribution. As traffic flows, we move to Step 3, metrics collection. Each region measures critical data like response times, error rates, and throughput.
This data is then sent back to the central metrics service every couple of seconds. This leads to step 4, real-time visualization. Your dashboard updates live, providing an immediate, color-coded overview of each region's performance: green for healthy, yellow for degraded, red for offline. You see exactly how your system is responding globally. Finally, we have failure simulation. This is optional but powerful. You can click Fail on any region to simulate a disaster, watching in real time how the remaining regions gracefully handle the redistributed load. This entire flow gives you unparalleled insight into your system's resilience. When running these tests, understanding the different system states is crucial for interpreting your results. First, the active state, often indicated by green. This means everything is running smoothly. Latency is low, success rates are high, and users are happy. This is your baseline, showing optimal performance under normal conditions. Next, we have the degraded state, typically yellow. Here, performance is suffering, but the system is still functional. Perhaps latency has jumped due to high load, or success rates have dipped slightly. Users might notice slowness, but can still use the service. Finally, the offline state, marked in red. This signifies complete failure. The region isn't responding at all. This simulates catastrophic events like data center power failures or severe software bugs, meaning users in that region cannot access your service. These tests offer immense production benefits. They help you find problems before your users do, validating your disaster recovery plans and building confidence in your system's capabilities. Take Spotify, for example. Their multi-region testing ensures seamless music streaming globally. When European data centers had issues, their testing had already confirmed that Asian and American users would experience zero impact thanks to automatic routing to backup systems with only a minimal latency increase for European users. This proactive approach saves millions and ensures user satisfaction. We've covered a lot of ground today, exploring the vital world of multi-region load testing. To recap, we started by understanding that multi-region testing isn't just a best practice, it's absolutely critical for building reliable, globally accessible services in today's interconnected world. Then we delved into the architecture, seeing how a robust framework leverages a dashboard layer for control, a service layer for intelligent load generation and failover, and a regional infrastructure to simulate diverse global traffic. We walked through the dynamic flow of a global load test from initialization and parallel execution to real-time metrics collection, visualization, and optional failure simulation. These steps empower you to uncover weaknesses before they impact your users. By mastering these concepts, you're not just testing, you're building confidence, validating disaster recovery, and making data-driven decisions that lead to truly resilient systems. Now for a quick self-assessment. How would you justify the investment in multi-region load testing to your engineering leadership, highlighting its tangible benefits and mitigating potential risks?